Hey guys, so today we're starting out chapter 9 with a pretty easy lesson, and it is over. Direct variation, and then there's going to be a second video that's going to go with this. It's going to be about reviewing for basic stuff that you're going to need to remember to keep going through chapter 9. But direct variation is a pretty simple idea, I think, and it actually doesn't have much to do with the rest of the chapter. It's It doesn't have much to do with anything, actually. It's something that they test you on, and so I'm going to cover it. But it's actually pretty simple if you just remember one equation, and feel free to not write all this. I will highlight what it is you should write. You should write all of this, all of that, right? Everything in purple. And then the example below. So you should probably write the title, and then this, and then read it. Well, direct variation is a set of data. A set of data is said to relate directly if both the independent and dependent variables grow bigger or smaller together. So the equation for direct variation is y equals kx, where k, this is a bit of terminology, on test or quiz questions, I'll ask you to tell me the constant of variation, and that is k in this formula. Now, another thing to point out is I will not give you this little equation on a quiz or a test because it's so straightforward. It's just y equals kx. It's not like the quadratic formula that you got to memorize this big long thing. It's just super simple. So here is an example. X and y vary directly. Y equals 10 when x equals 2. Find the constant of variation. Then find y when x equals 9. So the equation is y equals kx. Y equals kx. They say to find the constant of variation, which is k, when y is 10, x is 2. So all you got to do is you just got to plug 10 in for y, 2 in for x, and solve for k. So this looks a little weird to you maybe if you're not used to seeing things in this order, but that should be a lot simpler for you to think about what to do if you're not familiar with this way. In either case, you should choose to divide by 2 and divide by 2. And you would get that k equals 5. So there's our constant of variation. So this example is saying that x and y vary directly, and the constant that decides how they vary is 5 right here. So the next part of the problem says, then find y when x equals 9. So the equation is the same. It's still y equals kx, except now we know what k is. K is 5. And then we're trying to find y when x is 9. So you plug 9 in for x, and you plug 5 in for k, and you solve for y. So you get y equals k, which is 5, times x, which is 9. And so y equals 45. And that's it. That's the entire problem done. Okay. Let's move on to another way to see the data. Now, determine if the set of data varies directly. If so, find the direct variation equation. So this is another bit of terminology here. Direct variation equation. A direct variation equation is just y equals kx, but you have to plug in k. So whenever we complete this example, it should end up with y equals, and then whatever k happens to be, x, if it varies directly. So that's the first thing to worry about. Determine if the set of data varies directly. So we need to figure out if there is some constant that is deciding how you go from one letter to another. So remember, the equation is y equals kx. So what you want to do is you want to plug in, if this is x and this is y, you want to plug those in. This data set. You want to plug that in to y equals kx and see if k, well, see what k is. So we're plugging 1 in for x, so it'd be y equals, plugging 1 in for x, and actually plugging 4 in for y. So I plugged 4 into y, and then k times x, which is 1, and so k equals 4. All right. So for this set of data, k happened to be 4. Let's see what it is for this set of data. So remember, it's y equals kx. You're plugging in 2 for x, and you're plugging in 8 for y. To get k by itself, you divide by 2, and again, you get k equals 4. Now, you might notice a trend here, and this is good so far, by the way. Notice how we've got the same k both times. This is good. Like the set of data will not vary directly if the constant changes. So we're happy that it stays the same. Now, you might have noticed that you can do a bit of a shortcut here. If you can figure out every time, look what's happening. Every time we're trying to find k, what we're doing is we're taking y and dividing it by x. Right here, we took y and divided it by x. Here, we took y, which was 10, and divided it by x, which was 2. You can say that k, this is a bit of a shortcut, that k equals y divided by x, because in this equation set up here, to solve for k, you just divide both sides by x. So we can easily figure out k without writing the equation out every time by just taking y divided by x. So we're going to do that. So we've got y and x here. We're going to take y, which is 16, divide by x, which is 4. So 16 went here and 4 went here to find k. And so k on this data set happened to be 4. So again, we're doing good. K is 4 on this data set, which is great. And finally, we got to figure out k on the last data set. And so you might have figured it out already because you might be looking ahead. But it would be 20 divided by 5 right here, y over x to find k, and k is 4. So that's good. We now have a k for each one of the data sets, or each one of the points, and they all happen to be the same k, which is also great for us, because since every point of data shares the same constant of variation, we can say that the entire data set varies directly, and that the direct variation equation, which we were talking about earlier, is y equals 4x. So all you do is you plug the k in for k, and that is it. All right. This is the last example we're doing, and I would like for you to pause the video, try it yourself. I know you don't like to do it, most of you. But I'm not telling you to do it for no reason. You working out problems helps you understand problems. It's as simple as that. So, write this example out. Try to solve the problem. It says x and y vary directly when x equals -8, y equals 6. Find x when y equals 12. So see if you can figure that out, and I will start working it out afterwards. Okay, so I assume that you've paused the video and written it down and all that kind of stuff, and you've got an answer. So let's go ahead and see if you're right. So it says they vary directly. That means I know that the same k I find here, I will use here. So y equals kx. You're plugging in y and x and finding k. So you get 6 equals k times x, which is -8. Alternatively, you could have chosen to use the shortcut where k is equal to y over x, whichever you prefer. It's fine by me. But in this case, you'd still get 6 over -8 equals k. And over here, you would have to divide both sides by -8, which would end up getting you the same exact thing, 6 over -8. And so k equals 6 over -8, which reduces, divide the top by 2, divide the bottom by 2, then you're going to get 3/4, and it is negative. Now, a popular mistake, I don't even know if I call it a mistake, misconception for sure, misunderstanding that students have is they think that this negative sign is like mandatory to be put on the denominator, and that writing it out here is not the same, or writing on the top is not the same. They ask me, like, students ask me, well, should I put the negative on top or bottom? And I tell them, well, I look at them like, I don't know, man. It doesn't matter, because the whole fraction is negative if there's a negative anywhere. So this is exactly the same as this, which is exactly the same as this. It does not matter. So long as you're consistent with the number of negative signs you place, it does not matter where you place them. So tradition says that we place them in front of the fraction. And so we did. And so our answer is find x. Well, actually, we're not even there yet. Find x when y equals 12. So now that we know k, which is negative 3/4, you are going to use that up here. So y equals, so I'll use a different color here. Let's use this blue. Y equals kx. So k is negative 3/4 and y is 12. So you plug in 12 for y, and you plug in negative 3/4 for k, and you have x here. And now, to get x by itself, you have to divide by negative 3/4 or multiply by its reciprocal, which is negative 4/3, because the 3 up here and the 3 down here cancel, and the 4 down here and the 4 up here cancel, and the negative cancel. That's why we do this, to get rid of the negative 3/4. So we're going to multiply by negative 4/3. Oh, if I can fit it on here. Got it. Oh, you can't see the negative sign. It's there. It's right. I'm not helping things. Whatever. That number there is negative. So this works out to be, let's do some reducing, negative 16 equals x. Ta-da! If that is what you got, then bravo to you. Good job. And if you did not work the problem out, shame on you as always. And there's your homework. You have 4 problems to do. It should not take you all that long if you understood the lesson. And if you didn't understand the lesson, well then please ask me questions, because that's what you should be doing if you want to learn the material, which you should want to do. So that is it. Hopefully you guys understood the beginning of 9.1, and I will catch you on the next one. By the way, this should be an easy start to Chapter 9. Chapter 9 is, while many students find it not as confusing as Chapter 10, it's definitely not a fan favorite, I'll put it that way. So, prepare yourself.